6.3, graph using intercepts. So this is another way to graph. Right now, you know from a while ago how to graph using a table of values. It's the most annoying way to graph, but it's a surefire way. Just figure out what points equal what points, plot them, connect the dots. And then you learn how to graph using slope as intercept form, which is plot the y-intercept, figure out the slope, and then use rise over run to figure out your other points. So here we're going to graph using intercepts. So what are intercepts? So first of all, the x-intercept occurs when y equals 0, and the y-intercept occurs when x equals 0. Okay, so if you think of a graph, the y-intercept is on the y-axis. So this is the y, this is the x. The y-intercept is all on this axis. This is when x is 0, right? When x is 0, I'm right here. So any number on this line, the y-axis, is my y-intercept, and it occurs when x is 0. Likewise, to figure out my x-intercept, this occurs when y equals 0. So anything along the x-axis is the x-intercept, and this value of y is always going to be 0 along this line. Okay, so we use this knowledge of y equals 0, x equals 0 to figure out intercepts, because if we have a point here and here, all we need is 2 points to graph a line. Done. So sometimes if we can find the intercepts easily, we will, just so we can graph easily. Okay, so first we're going to find the intercepts for this equation right here, 4x plus 6y equals 48, and then we're going to graph it. So the first thing I'm going to do is find the x-intercept, and this is when y equals 0. Now what do? I actually just plug in 0 for y. This is 4x plus 6 times 0 is 48. This is gone. 4x is 48. Solve for x. 48 over 4, x equals 12. I found the x-intercept, 12. I'm going to do the same thing for the y-intercept. This is when x equals 0. So I'm going to plug in 0 into x. 4 times 0 plus 6y equals 48. Gone. 6y equals 48. Divide by 6. Y equals 48 over 6. Y equals 8. Now I found both intercepts. So if I'm graphing this on a Cartesian plane, okay, or a graph, whatever you want to call it, then all I have to do is plot my y-intercept, 8, and plot my x-intercept, 12. This is where at 12 it intersects the x, at 8 it intersects the y. Don't connect the dots from here to here. Draw a line through the dots with arrows on both sides, and this is graphing using intercepts. Now, some guys are probably thinking, oh, this is a lot of work to show. Do I have to do it this way? And I'm saying, absolutely yes, you have to do it this way. Because only by practicing it this way will you become faster at doing it this way. And eventually you can just understand that, well, I could just hide. If I'm multiplying by 0, just hide it. Look at that, 48 over 6, done. 8. I could just hide the 6. 4x is 48, so 48 divided by 4, 12. So you could do it quickly, but that's going to take practice. And only by practicing something that seemingly is useless will it appear to become useful later on, whether it's next year, the year after. So just trust the system. Graphing using intercepts could be tedious right now, but I assure you it is an excellent strategy to graph. Okay, so the last question I want to go over in 6.3 is figuring out a slope of a line using the y-intercepts. Or sorry, the intercepts in general, the x and y-intercept, and how can we come up with an equation using the intercept. So this is kind of going backwards. So determine the slope of the line with an x-intercept of -4 and a y-intercept of -6. So a big issue in this chapter is going to be coming up with points. Once you have 2 points, you can figure out slope, you can come up with the equation, you can do anything. So the fact that the points are hidden in language is probably our first obstacle that we have to overcome. So this is pretty straightforward. I mean, if the x-intercept is -4, it means that the point is -4, 0. Because the x-intercept occurs at y equals 0, remember that. And this one is the y-intercept of 6. This is 0, -6. These are my points. Okay, now I'm going to graph this. So simultaneously while I solve this, you'll understand how to find slope. Here's my Cartesian plane. This is 1 point, 0, -6. The y-intercept is -6. Y-intercept of -4, sorry, -4. Okay, so this is going to be my line. So look what I noticed right away. 2 seconds, crappy graph. Let me label my axes. I know the slope is negative right away. So if I'm getting a positive number as my slope, I'm wrong. Negative. Clearly, it's negative. Now, I can easily do rise over run to find slope. Slope is rise over run. 6/4, but I know it's negative. Slope is -3/2. So look how easily I figured out the slope using a quick little sketch. Okay, I understood that it's negative, so my answer has to be negative. Or you can think of it as -6, +4. Or you can think of it as -4, from here, +6, -4. Doesn't matter which number takes the negative. It's still -3/2. It's still -1.5. Okay, so let's use slope formula over here. Okay, so slope formula is, I guess it's a new formula. I'm going to go over it a few times each lesson now because we should get the hang of it. Slope formula is delta y over delta x. This is really rise over run. It's just a mathematical way of saying it. Delta means change in. Let me write that down. So it's the change in y divided by the change in x. How much is my y changing? Sorry, my y, and how much is my x changing? Okay, this can break down further into y2 minus y1. Take one y value, subtract it by the other. This is how you find change. And you do the same with the x's. Okay, now, this little nomenclature under here, this 2, this means that these values come from the second point. So y2 and x2 come from the second point. You decide which point's the first, which point's the second. So if I call this the first point and this the second point, y2 is -6. x2 at the bottom is 0. This is x2, this is y2, because I called this the second point. You can flip them, doesn't matter. Now I'm going to subtract y1. y1 is 0. x1 is -4. Now this is wrong if I put -4 because I'm subtracting -4. So be aware of brackets in slope formula. If I were you, I'd put every single number in brackets and make sure there's a negative sign between them and you'll be okay. Okay, so now -6 minus 0, done. 0 minus -4, this is +4. Same thing. Okay. Sometimes if you can graph it, it's really easy to come up with slope, but you need to know slope formula. This might be intimidating right now for some of you just because of all these Greek symbols, and this is the Greek letter D, by the way, delta, and all this nomenclature that you might have not seen before. But we're going to keep using slope formula pretty much every lesson from now on, and I assure you, you will get the hang of it. If you have any questions, make sure you post it, and I will answer them accordingly. Okay, so finding the slope of a line is that easy. Actually, let's continue on and do the equation of the line. Since I know the slope, the equation of the line is y equals -3/2x. Now over here, I just need my y-intercept. Well, the question gives me my y-intercept, -6. Done. So coming up with the equation of a line using intercepts, really, really easy once you find slope.